Welcome to today's webinar on experiences in the use of digital construction management in the highway industry. Today's webinar is hosted jointly by the Joint Technical Committee on Electronic Engineering Standards and the Committee on Construction. I'm Patricia Bush, Senior Program Manager for Bridges and Design at AASHTO, and today I'm co-hosting with Casey Sonera, Program Manager for Engineering and Liaison to the Committee on Construction. Before we get started, a few housekeeping notes to help you enjoy today's session. All attendees are automatically muted for the entire webinar. If you have questions at any point during the presentations, you can submit them by using the Q&A button on your Zoom webinar control panel. We will answer them as time allows at the end of the webinar. This session is being recorded, and the link will be made available on the Joint Technical Committee on Electronic Engineering Standards webpage. You can navigate to it by going to transportation.org/design and selecting Technical Committees, then Electronic Engineering Standards from the menu on the left. An email with a PDH certificate will be sent to attendees who stay for the entire webinar. If you can't find it, be sure to check your spam or junk folders. Download the certificate and keep it for your records. Now I'd like to introduce today's moderator, Tisha Clark, the State Construction Engineer for New Mexico DOT and Vice Chair of the Committee on Construction.
Good morning, everyone. Welcome to the fourth and final installation of our quarterly webinar for this season. As Tricia noted, this is a unique webinar as we're combining with the Joint Technical Committee on Electronic Engineering Standards. It's great to have such a large audience. Today, we'll be exploring the key findings from a recent domestic scan focused on the successful adoption of digital construction management, or DCM, innovations. With advances in digital construction evolving every day, it is essential that these technologies be deployed and adopted effectively. This session will focus on implementation practices. The goal is for you to learn how your state can use digital construction to drive safer, more efficient highway construction programs. We also want to improve each session to deliver content and collaboration in a way that is most accessible and digestible to you, our members. If throughout this session you find ways that we can improve, please feel free to contact either Casey or myself with these suggestions. So we're going to start with about a 60-minute panel discussion and then finalize with about a 15-minute Q&A. So we have great speakers today. Sean Smith is the Senior Project Manager with Maine DOT. Ramon Hopkins is the Chief of the Division of Construction at Caltrans, and he has with him Aaron Chamberlain, who is the Senior Transportation Engineer at Caltrans. With that, I'm going to turn it over to Sean.
Good morning and good afternoon, everybody. I just want to make sure you're seeing my presentation. You should be. You get a thumbs up, Ray? Can you see it?
Yep, looks good.
Excellent. Well, anyway, good morning, everybody, and good afternoon if you're on the East Coast. Ray and I are going to tag team this, and we were both part of the Domestic Scan 2202. And so what we're going to do is I'm going to kind of go down through a little intro and talk about the domestic scan process a little bit. And then Ray is going to talk about some of our key findings, and then we're going to turn it over to Aaron. So I want to welcome everybody. If you can silence your phones and give your attention to us for the next hour or so, that would be awesome. So away we go. Now this is part of this PowerPoint presentation. It is from the domestic scan, so we have our views and opinions in this presentation classifier. So the content of this presentation, it's our opinion and what we saw from the domestic scan, and I won't read the whole thing for you, but there is our disclaimer. So the domestic scan program, it's a program that it conducts 3 to 4 scans per year based on topics that are relevant to our industry. Projects are selected by AASHTO and NCHRP, and as well as the panel. Each scan will address something that is of a technical topic of broad interest to many of the states, And our topic is advanced digital construction. So the topic that we're going to speak about today is everything that we're currently growing as an industry, as state agencies trying to use the technology to the best of our advantage. And each state that participated in this domestic scan is doing a wonderful job leading change and fostering innovation. So we really want to hear throughout this scan what we heard from each state was pros and cons of some of the things that they're developing, some hazards along the way, and also some really good benefits. And I think, you know, our journey towards digital documentation, digital construction management, there's a lot of things in play, and you'll see today through our presentation that there's many topics that will cover us through a digital platform. So, of course, why a domestic scan? Well, you know, there's changes with time, and processes will change. As you can see from the old transit to the old drafting rooms, you don't see that today. So each one of our state agencies, our business practices have had to change. We've had to adopt new policies, new procedures, and we've had to embrace moving to a digital world. When I began my career at Maine, I do remember the drafting rooms. We started seeing computers in the mid to late 90s for some of our drafting and design work. But I remember coming in from construction and talking with one of the designers that was in a sea of drafting tables and saw all the scales, slip sticks, you know, you name it, it was all over the place, and they were hand doing everything. So time changes, and we need to change with that, and that's a big part of this particular domestic scan. So with change, we've gone from paper plans to beginning the discussion moving towards 3D models, and of course, moving towards 3D modeling. This is a picture that we did of a roundabout in Maine in 2013 that we did push through a model. Our contractor embraced the model, and the model down below with the little mini excavator on it was their software actually showing materials management, how best to cut and fill and where material could go, because we were relocating an existing interchange, and there was a lot of usable fill as part of this project. And so using some of the software, they were able to try to maximize haul routes, try to maximize that use of materials, which is one of the things that going digital can allow us to do. Lots of times in construction, that was 100% relied upon, with a superintendent or a foreman being responsible for planning out where things are going to go. And usually that was on the back of a tailgate with a half-size set of plans that was broken apart and bolted together with a couple pieces of wood to keep everything together. And they basically built things in their head, and they organized their crews to go and implement what they had in mind. This computer aided and digital type platform kind of helps us do that to a little bit better efficiency, because you can run some different series, different analysis, and you can make decisions based on some of that, but you still need that experience out in the field. We can't forget that. Just because these tools are digital and they do save a lot of time and they have a lot of benefits, we still don't want to leave the understanding of how things are built behind. And when we do leave connectivity, we want to make sure that we can still keep working. And as we talk through today's presentation, we'll talk about some of those challenges that we have. So when the domestic scan panel was put together, the intent was to pull from state highway agencies what they're currently using in an electronic construction management process. Like I mentioned earlier, a lot of us are developing at different paces. Some of us are using different products, different software packages. Some of them may be homegrown. Some of them may be more of a commercial product that has been customized to each state's individual needs, which is good, but it also can be challenging when you start talking about interoperability and sharing amongst different platforms. Digital construction management also builds upon pretty heavily 3D modeling. As part of an e-construction documentation plan, digital as-built, and of course, e-ticketing has been a hot topic here in the construction world for the last few years, as well as unmanned aerial systems. We're finding more and more uses of unmanned aerial systems, and Ray and California and Aaron is going to talk about that this afternoon in a little bit of detail. And of course, smart work zone project coordination, using a smart work zone technology, it's not only a technology that can help us warn our traveling public, warn our customers about what's coming up, but it's a safety factor. Smart work zone technologies can enhance safety of our work zones, which is very important to not only the traveling public, but our workers that are out there. And of course, we're all struggling with staff. Workforce development and innovation is a huge thing amongst every agency and in industry in general. So how do we leverage this technology to recruit new people? When I grew up, and many of us grew up, we did not have computers until we were well into our teens. But younger generations have been accustomed to phones and computers early on. So using this tech, we're really hoping that can be strengthen our workforce development and really kind of grow our industry. It's just how do we get this information out there and make sure that they understand that this is something that we do, and we do have tech. The other part of the panel too is we want to talk about real case studies, real uses in construction. How does this benefit our construction industry? How does it benefit our state agencies? Does it reduce paper? Does it reduce processing data? Is it, a security issue of going from an inspector to a resident, in a real-time format, so the resident can be up to speed with what's going on a project that may be large with multiple activities, or even for payment. We want to make sure that also our staff is trained in some of the newer technologies as well. The two photos you see are from a project that we had here in Maine that you can see the bedrock embankment on the picture to the left. And we used a rover in our model to basically take ledge shots before we removed the ledge. And then we took ledge shots afterwards. And we used the 3D model to compute a volume of ledge removal. So that right there, in that use, the old-fashioned way was we would set up an auto level, go out and take shots, put the notes in a book, take shots after the ledge was removed, take those notes and put it in the book, and then set down and hand plot on a set of cross sections and actually physically comp that volume. Now we can do it digitally. We kind of eliminate the step of the handwork, but we need to do a verification too. We need to make sure that all of our areas are coded right, they're flooded, and the volume makes sense. So when we use this on this particular project, we did individual shots and our contractor did different shots, and we compared the two volumes. So we kind of worked in unison to try to use this technology to our benefit, but we also didn't want to have huge differences in that volume computation. So again, learning, baby steps, trying to use the product to the best of our ability, try to educate our staff, but also to gain confidence in it. And I think, that's some of the things that this domestic scan comes out with is successes on how we're learning to use this and the benefits of it. And lots of times it's just not a paper reduction. That's a big part of it, but it may not be. It may be that use of transfer in e-ticketing software to see real-time load delivery tickets and where units are between the plant and the laydown area. So there's a ton of benefits here, and like I said, we're all trying to use it and grow that technology. The other thing that our panel was tasked with doing is we wanted to identify effective, accelerated deployment strategies for digital construction management. You know, time is money. It's not only money to the contractor, but it's money to our users. You know, commonly when we have a large project, we'll do a user cost analysis, look at some different ways to shave time, and working through that to come out with the best product we can at a super high quality. The picture to the left is our Veranda Street project on 295 in downtown Portland, Maine. You can actually see a little video of this, down at the bottom of the slide in yellow. See the 60 incredible hours, the Veranda plan on YouTube. If you have a moment, that's a great short video to watch. Working with our contractor here, we had 60 hours to remove 2 bridges on Interstate 295. This is one of our busiest sections of the interstate here in Portland. Completely remove it and put 2 new prefabbed bridges in its place and have it reopened in less than 60 hours. The video will kind of speak for itself, but again, you know, using that accelerated view of how can we best, you know, minimize traffic disruptions, how can we create things off alignment and move them in. You know, that analysis is not only aided by a digital concept, but it's also that collaboration between industry, design consultants, our contractor partners, and also the state agencies. So a lot of this digital delivery, it's really about seeking efficiency as well and better ways to do things. We're going to talk about a little bit of best practices as well through the learning curve of all these, and also talk about national observations throughout this domestic scan. Like I mentioned a couple times already, there are different paths that states are taking. So nationally, if we can all share this information, we can learn from each other and actually begin to build towards using these to the best ability that we can. Our panel consisted of John Hancock from Georgia, Brian Cawley from Federal Highway Administration, myself, Ray Hopkins, John Dunham, Tyler Carlson, Wade Johnson, Damon Ziegler, Jace McKeon, Eric Clausen, Charlie Bauer, and Chris Newman. And all of us actually participated in not only talking through what we wanted to get out of this domestic scan, but helping with the survey that went out to our states, coordinate our presentations from our experts on the subject matter, because each state has a subject matter expert on the particular digital delivery and digital construction management systems that each state is using. So we all came together, came up with a plan. Then we went out and got our presenters, and we did a pretty deep dive into some of those technologies. Again, here's some of the states that we actually did as part of our workshop. This was all combined into a workshop format where we actually had 5 days of presentations throughout the days from different states talking about different digital construction management technologies. So some of these that we focused in on through the domestic scan is basically electronic document and retention policies and procedures that some states were looking at, electronic systems for payroll, which I will talk about later this afternoon as well, interconnectivity standards, surveying with digital devices, tracking progress and performance, unmanned aerial systems for inspection and mapping, e-ticketing, processes to advance and pilot and adopt new innovations. These tools are all new, and we're trying to see how they best fit. And as well as utility locations. One of the most frustrating things for us in construction is we constantly run into old utilities or improperly marked utilities. And so if we can get those mapped accurately and get them shared with everybody, we're leaps and bounds ahead of the old-fashioned way of seeing an old set of as-built and just transmit it to a set of plans. Some of the other innovations, of course, is digital as-built, smart work zones, like I mentioned. I won't go through all of them, but you can actually see how they're all integrated, and we're all trying to use different things to improve our processes. And this domestic scan really kind of helped expose those to states that may not be aware that there are some of these systems out there. We went through and talked about the good and the bad, and that discussion was all part of the virtual workshop that I mentioned. So we had a 5-day workshop in June of 2023, panel presentations and also panel discussions from 2 to 3 states each day. And we talked in detail about each one of these digital construction management systems that we were using. Again, talked about how did we implement them? Why did we choose what we chose? How did we fund it? How did we make it so the contracting community or our consultant engineer community was able to use these systems to be part of our process? We had a lot of Q&A, and we had a lot of discussions. And after our virtual workshop, we had several panel meetings to try to pull together all the information, and we've published the final report. So part of our big discussion, like I mentioned a little bit ago, is where each state is with each advancement. Are they implementing or are they not? What development stage they're at? Because until you get in using a lot of these systems, you really don't know what their capabilities are and what type of challenges you have to make them work within your business platform. You go through a pilot, you assess it, you make some adjustments, and then it becomes part of the normal process. This afternoon, I will talk a little bit about our Elations system. It's a payroll interview system that I'll get into. But again, we followed that same type of process. We were not using it. We piloted it. We liked a lot of what it did, and we started to make it part of our business practice. And that's part of our construction staff's duty to do payroll interviews through Elations systems. So a lot of these followed the same process, and a lot of them, they went back and forth as technology changed and as updates happened. So some of the specifics that each state kind of contributed to part of the overall discussion. Maryland had software interconnectivity and standards. Maine and Wyoming did the electronic systems for subcontracts, payroll verification, prompt payment, EEO, and Davis-Bacon interviews. Georgia, Pennsylvania, and Utah did project site documentation with photos, scans, retention of that data, because as we move into a digital platform, what do we do with that data? How do we handle that data? Nebraska, South Carolina did surveying with digital devices and talked about some quality assurance checks to make sure that things were checking out. And California and South Dakota, unmanned aerial systems for inspection, mapping, and I think you'll hear from California today some pretty amazing things that they're doing. So that's a great segue. I'm going to turn this over to Ray, and I'd like to introduce Ray Hopkins from Caltrans.
Thank you, Sean. And once again, I'm Ray Hopkins with the California Department of Transportation. And, that list that Sean was just previously showing goes to illustrate there's just so much going on out there. There's so many innovative things. This report could not cover them all, and we're obviously not going to cover them all today here. But what I would like to do is just hit a few of the highlights from some of the individual states Then I'll talk about the summary of findings of successful implementation, and then what the key recommendations of the report were. So as we went through these interviews in this scan, California, some of the points there was, innovation. We had to change our paradigm, and innovation isn't a cost; it's an investment. And as we invested into new technology, we were looking and monitoring our return on investment. It was really important to watch that, to convince leadership or to maintain that relationship with leadership that this is a positive investment. The development of dashboards were being used internally, and still now exploring methods to share more information with our contractors. And I think you'll see that as a reoccurring theme through here, is that transparency and information sharing with industry is a significant point if we're going to advance technology. Pennsylvania started talking about, you just got to do it. Start taking risks. You can't wait till you have 100% solution for something. So take those risks, start implementation, and then see the benefits. But really behind that was getting that key executive support for that long-term commitment and funding for implementation. South Carolina, once again, collaboration. They hit collaboration as the key with the construction program. And as their program's expanding, they're bringing on more consultants and more contractors. And what they're finding, that is an opportunity to collaborate, to see what industry has out there, what's over the horizon, what are they seeing coming in as new technologies, new tools. And then improving this partnership, this collaboration, not just with contractors, but with service providers, with the equipment development, with the program development. I did want to just mention here on the left side, this slide, one thing. This is in California, and we're working with robotic equipment. So on the top slide, the operator is actually sitting in a Connex box there near the job site. This is an active slide, and it's really important. This is on Highway 1. But as the slide is still active and politically trying to get this back open, we had to continue to work. So we were able to get some robotic cats out there. And you can see maybe in the bottom of that picture, there's a couple observers out there just for safety. But this was a way to look outside the box to advance technology. Now, this really isn't necessarily the digital construction inspection, but it is capitalizing on new innovations and robotics. Go ahead and go to the next slide, Sean. So Utah focused on material testing in their construction management system. They developed this independently, but with that relationship, with that collaboration with AGC, they were receiving good feedback, and they had to count on the contractors to be innovative. That helps them progress. So working once again in collaboration with our partners. And then they're using their material management system as a single source of truth, a single source of information that is shared with them and the contractors for material acceptance, for payments, for quality assurance. Sean said he's going to hit elations later, but when we think digital construction inspection or digital construction management, it's really easy to go to the robots and the BIM for infrastructure and the engineering side of things. But I think it's important when we look at it holistically, we continue to consider our labor compliance tracking, our prompt payment, our DBE programs, everything else that is part of what we do as state transportation agencies. Georgia did a lot of discussion about the e-ticketing. They began back in 2021 with their asphalt, and they're seeing expanding that program, looking at the success and looking at the efficiencies that they've received, and starting to apply that to aggregate and concrete. And really, it just requires coordination with industry. Once again, this is the collaboration between the owner and the contractor, and I always say that together we're industry, and that collaboration is key. All right, let's go to the next slide. So here, talking about some of the summary of findings, fostering a culture of innovation. It really is that this is an investment. It's not a cost. There is a return on investment that we're seeing as we track it, and other states were saying that as well. But it requires that leadership support. And before we're spending millions of dollars on implementation of a system, we need to show that this system is a return on investment and being implemented in other areas. And that's why it's important to share information like this, sharing the resources with other states. There's really no reason to reinvent the wheel, or as we say, the R&D, the rip off and duplicate. If something's working well in California, we're happy to work with other states, and likewise Maine. Any of the other states would say the same thing. Partnering with our industry for the solutions. And then I put the motivating and innovation core. And I'm going to introduce Aaron Chamberlain in a little bit, but what I see is that core set of energy, those employees that really want to make a difference. And when you have that core of employees and contractors that want to make that difference, we can influence the laws, regulations, and policies. We can make sure that our strategic initiatives are aligned with embracing new technology. And we really have an excited group of individuals and groups. Go ahead, Sean. So managing change. Change is hard, and we all know that there's an art to change management. And truly, it's about supporting the networks, the training networks, integrating the construction management systems. The short and long-term data storage has been a challenge with this change. I think a lot of states are looking at that. We may talk about that a little bit later. But as we store this data, we collect this data. The picture on the left, training on drones, getting our staff well trained with the physical operations of a platform. That's the first step. The second step is managing all that data that's coming in, and what are we going to do with that? And then mainstreaming innovations. Really, this is where, in my mind, all the states have been very good at focusing on efficiencies. Processes lead to efficiencies. But with the rate of change of technology, our processes are holding us back, and we need to look at adaptability. How are we going to be adaptable to really mainstream new innovations? Go ahead, next slide, Sean. So this is about one of the key findings there was building a culture, embracing the innovation, construction management, really looking at what I was saying earlier, the rate of change. As things change, they continue to change faster and faster, and being able to be adaptable to embrace those by identifying those opportunities and investing in the solutions. This was a uniform amongst all the states, regardless of what they were focused on in the study. They were all talking about having to look at that rate of change and identifying those opportunities, looking over the horizon. Go ahead, Sean. So I mentioned a little bit about addressing the data storage needs. This was another universal topic that was coming up, was the ability to have multiple types of data and file. Looking at both the storage needs and the retention policies, making sure that our current retention policies honor the vast amount of storage. As we're looking at BIM for infrastructure, we're looking at a huge amount of data. What is that data that's necessary to maintain, and what data can be transitioned? At the same time, making sure your data is searchable and retrievable. If just having data for data's sake is irrelevant unless the right people can be able to get it at the right time, and having those different systems being able to interact and talk to each other. So having that common data language. Another challenge was the number of users accounts that we see both for state, and then as the contractors are feeding into that data, the number of users accounts and the security and hierarchy of needs there. And then the system compatibility. We understand that our vendors are starting to talk to each other and making sure that we're not going to be married just to one system forever, that data is interoperable. Next slide. So as a conclusion and some of the recommendations, really, this report was looking at deploying proven digital construction management innovations. Once again, not at reinventing the wheel, using those peer exchanges, using venues like this to say, oh, these are things that are out there that we can capitalize on. Fostering that culture, it's getting that core group of individuals and contractors that really want to make a difference and fostering and enabling them to act. Managing that change, understanding that we have to shift from a fully focus on efficiency to being more adaptable. Promoting those emerging technologies, the things that we say, wouldn't it be nice if? Wouldn't it be nice if we could have this or do this? And working with our vendors to help them develop the programs and the tools that are going to serve us. Sharing all of our good stories and our bad. I have to be able to say, hey, we tried this and we struggled with it because of these reasons, but we found success over here. And at the same time, listening to what other states have to say and where they had the pitfalls that I may be able to help them and they may be able to help me with my struggles. So these peer exchanges, AASHTO Committee on Construction, I encourage everybody to be involved with our peers nationwide to solve this. Using these peer exchanges and education, and then building a culture of innovation. It really says, we said fostering a culture of innovation. It's building a culture of innovation. It's really bringing together everybody that wants to make these changes and see what the possibilities are. And, finally, this is an investment. It's not a cost. And we can say, oh boy, employing these systems just cost prohibitive. But one thing, as Aaron, I introduce him here in a minute, we invested in, say, a robotic dog, and that's a big cost. But after just a couple missions, it has more than paid for itself in cost savings. So really capturing that return on investment. Okay, next slide. So there's a couple links here for information. It has the entire NCHRP 20-68 report, and then you could also look at the domesticscan.org for general information on the domestic scan program. Sean, next slide. Okay, before we open it to questions, I'll ask Sean to stop sharing, and I want to introduce Aaron Chamberlain. He is one of my engineers, and he's one of these core innovative minds. I often joke that I've given Aaron enough rope to hang me because I want to enable him to act. I want him to run and use innovation and do what he can. So I think he's going to cover both the investment that we had in our robotic dog and some of the savings, and then some of the work we're doing in collaboration with Alaska with the drones. So Aaron, I'll give the floor to you.
Thanks, Ray. Hopefully everybody is seeing a pause video. Give me a thumbs up if that is correct. All right, excellent. So again, Ray mentioned the robotic dog. What the heck could that possibly be used for? I'm going to show you really quickly. This is our Spot robotic dog. So this platform is made by a company called Boston Dynamics. We have equipped it with an Emosint hover map system, which is a SLAM LiDAR system. And this is one of its first kind of debut case uses that we found an immediate large return on investment. So this is a failed culvert. So we had, this is up in Highway 101 on our north coast, up in District 1. So this is a failed culvert. So there was a large sinkhole opened up in the middle of the roadway during heavy downpour storms. The entire highway was closed here. And as you can see, I've got side-by-side view of the point cloud that was generated from the robotic dog system. And then you can actually see the live video feed on the left, and up on the top, you can kind of see the profile view. You'll see here that entire culvert was shifted and failed almost 1.5 feet down. Those things dangling from the top that look like traffic cones were traffic cones. Those had been sucked down from the sinkhole from up top. But the big picture here is, okay, why did you need to scan it with this tool? Why couldn't you just do this with other means? Well, most likely we could have. However, the advantage here was in about a 7-minute scan, we were able to walk the robotic dog through the culvert all the way up over the top of this site. Our engineers were very quickly able to download the data off of this system, quickly generate a point cloud. and then be able to start to make some engineering decisions based off of that. I'm going to skip forward a little bit because you don't need to watch the entire video here. But this is where this gets important, right? So here we have a point cloud that's been classified, be able to be extracted. And the most important thing that we solved here was speed of quick engineering decisions that were sound and highly accurate. So in this case, we were able to quickly ascertain the overall depth of the repairs that were needed, the length of the culvert, and actually the most important thing was a shoring design that we were able to quickly implement using some tools, frankly, from Trimble that we are typically using, that we're able to design shoring and trenching for this that determined that we were not going to have to be able to do a cut bench into the adjacent slope, which best we can figure, we saved close to $100,000 in lost time and again cost, because without having to use engineering shoring, we were able to use standard shoring. We knew exactly how much culvert we needed, and with that, we were able to very quickly make those repairs. I think they were complete with all of the repairs within 3 days. Typically, those types of repairs takes us in excess of a week. So again, less impacts to the public. No employees had to go do that entry. And we were able to get very quick engineering, sound engineering based decisions be able to made with that data. So again, it's a very similar case use here. So this is inside of one of our bridge soffits. So we have a big project that's planned right now for this bridge. Again, this is up in District 1 where we've deployed the first robotic dog to. So we were able to, walk through this site, scan the interior. So normally entering confined spaces like this requires a lot of additional effort. We may or may not need air sniffers, air handling equipment, et cetera, depending on what we have inside of those environments. In this case, we don't have to do anything. We can send a robotic dog in. We don't need confined space entry permits. We don't need any of that stuff. Very quickly able to collect that data. And I would say the bigger thing here is, and I want to highlight this, being able to publish this into these connected data environments or common data environments you might hear for BIM. So it's not just a tool that's collecting data out in the field. We're able to bring that back. We're able to federate that with design data and merge that with the design intent and quickly make decisions and extract insights from that. So that was what I wanted to share with that. I'm going to stop sharing that, and I'm going to share the next innovation. Give me just a second while I queue that up.
As you're queuing up, Aaron, and I don't know if everybody else has, the videos lagging a little bit from what he's talking about, but I will just point out one of the biggest cost savings that we saw is that culvert. When the dog walked through it, the big lesson that we learned was that the culvert was not in the alignment as the as-built. There was a kink in the culvert. So where that failure was, if we were to exploratory dig from where the sinkhole was, we would have had a huge pit that we would have been opening until we got to the culvert. By the use of this, we were able to laser focus our excavation and our repair, and then save a lot of time and a lot of money. And I think the savings on that alone was enough to justify the cost of the dog.
All right, so the next thing I've got queued up is kind of a advancement in unmanned aerial systems. So actually, before I share that live screen, that should have gone to the video. So I'm going to share a portion of a video here on this. So this is a big initiative that is actually a co-initiative with us and Alaska DOT. So we, both Alaska DOT and California DOT were recipients of a Round 1 SMART grant for the use of autonomous UAS systems, specifically dock-based. So here, that should be going now. Give me a thumbs up when that is actually being shown, Ray. Good. Okay, so you can see here, Alaska DOT and California were co-awarded $12.4 million for what we're calling Smart Round 2 or SOAR, Scalable Operations and Advanced Remote Technologies. You can thank Ryan from Alaska DOT for the fun acronym there. So this initiative is going to be putting roughly 60 dock-based systems in places all over California and Alaska. Next question is, what is a dock-based system? So drones were used to being used, right? The crews drive out, you charge them, they hand fly them from out on the site. collect data, bring it back to the office, do the processing. That's been the way it's been since about 2016 when we started first using drones. Well, now these things can actually live out on the job site, potentially full time. That's the big innovation now, is I can fly these things remotely, and all of the data is able to be transmitted via cloud, via Starlink, up to our different systems that we want to connect them to. There's a variety of different APIs that are available that I'll be showing here in a minute on exactly how we can go about moving data from one source to another. But again, the huge innovation here is we don't have to have a person on site. So thanks to our partners with Skydio, we not only have a system that is operable, but also waivers to be able to operate those systems. So today, California, I'm proud to say, has waivers for 10731, 10739, and 107-145 for beyond visual line of sight, shielded operation waivers, operations over people and traffic, out to a 200-foot shielded ops. Meaning effectively we can operate a drone within kind of a 200-foot bubble of our roadway or bridges, anywhere in the state in Class Golf airspace. And we recently received partial approval for kind of a major site that you're going to see here upcoming in the next few months, which will be Coronado Bridge. So we'll be having one of these dock-based systems on one of our major structures in San Diego, and heavily congested military and Class Bravo airspace for Lindbergh Field. So I think it's a major innovation there. Before this goes too crazy, I'll show kind of the back end of this, which is, again, the operations of the drone stuff is one piece. I actually think the area where we're seeing the most improvement and the rapidest growth is actually in the back end, right? How do these different systems connect to each other? How do I actually get real insights from a drone system? So again, you're seeing here an API that we're able to connect from the Skydio system, from the Skydio cloud, into our Trimble Connect system, which is one of our connected data environments that we're testing, or our common data environments for BIM that we're testing. So with that, I can autonomously pull that data in. I can do my processing. And then I can get to the point where I'm actually starting to share this data. So, what does that look like? Well, now we've all seen the structure for motion photogrammetry stuff. Now it's happening without a person having to go out to the site. And that's really the big game changer. So potentially every day I can have the drone fly the entire project site if I need to, automatically download all that data, process that data, turn it into these, highly registered point clouds. We're also seeing some advancements in some of the other rendering technologies like Gaussian splatting to really enable ultra high resolution reality capture to our sites. So I'm going to stop sharing the video, and I'm going to go to the interface, because I think seeing we like to use this phrase, seeing is believing. So I want you all to see something.
So this is a point where I'd encourage everybody to get out their iPhone if you have one, or your cell phone, and Aaron will put up a QR code to scan. And it's not to make donations.
So give me a heads up if it looks like you're just seeing a web interface.
Yes.
All right. So I've already pre-flighted this system. I know my airspace is clear, so I'm glossing over a whole bunch of stuff on the back end that needs to happen for this to happen safely. Rest assured, it's already been done and completed. But I'm going to literally fly a drone live. This drone is located about 50 miles from me right now, out on one of our active construction sites. So you'll see the system kind of getting queued up here. And before I take off, I need to be paying attention to the interface. Y'all should be seeing a QR code. Give me a thumbs up if you got a QR code.
Okay, and
all right. I'm going to give people 10, 15, 20 seconds for that. That's going to be really critical, because what I'm going to be sharing back through the screen is going to be heavily deprecated data because of the streaming interface. But if you're connected via your phone, you're going to get a full 1080p video feed that's live directly off of this system. So I'll give people a couple more seconds, and then I'm going to go ahead and launch the drone. All right, so drone is going airborne. Now, in theory, that live stream should be live. Give me a thumbs up if somebody's got that. All right, we're live. Okay, so to save a little bit of bandwidth on myself, I'm actually going to stop sharing. So hopefully everybody was able to pull that up on their screen. And again, this is all live, so what could go wrong, right? I'm operating a drone system remotely out on a construction site. So as you can see here, we do have contractors working in the area. Hopefully that live feed is going right. You're seeing trucks working. We've got cranes working. So this project is a $120 million total value bridge replacement project over the Sacramento River in Northern California.
And Aaron, just for everybody, it did go dark on mine, but I reloaded and it worked fine. So
Okay,
I
yeah.
didn't see.
If you get a glitch or anything, just hit refresh. It should come right back up. So again, this is live video streaming. So, lots of case uses for live video streaming for, construction inspection, emergency response. We happen to have this system up a few months ago during some very high water events where we had a lot of debris that was coming down from a river that had jammed up against it. We actually couldn't even get staff out to the site at the time. But I was able to have this drone system out on site operate and be able to give those insights directly to the engineers at the time. So again, video is great, but what's better than video is actually the ability to do RTK or PPK structure for motion photogrammetry over sites like this. So now not only can we be doing live video streaming and things of that nature, but now we can actually remotely operate, collect tens, thousands of photos, reconstruct those in our structure for motion photogrammetry software, or now kind of the emerging reality engine type stuff like you're seeing from like Esri. Where we can create Gaussian splats, overlay that data compared to our BIM data, and now we're really doing real-time verification or near real-time verification of construction activities that are happening. So now what I'm gonna do right now is command the drone to go ahead and come back to its launch point. So you'll see it's kind of retracing its steps right now. There's a couple of different return modes. This one is basically an autonomous return to home. So it's flying itself back to its dock now. It's going to tuck itself back in. And you'll see here as it lands, kind of what that looks like. So this specific instance was hardwired. So we had 120 volt power out at the site because it was co-located with one of our cores or our continuously operating reference systems. But our future builds are all going to be what I call off-grid. So we're in the process of fabricating somewhere around between 15 and 20 shipping containers that have solar panels, battery backup, Starlink, and cellular connectivity that'll allow us to basically plop these things out on any one of our job sites and operate them just like I am right now. So it doesn't matter if it's out on the North Coast where I have zero cell phone connectivity, or if it's right in the middle of downtown LA or San Diego, on a major structure. These systems are here, they operate. We've conducted hundreds of flights with this system now with 100% reliability. So I would say that's another one of the big things that we're seeing from the industry right now is not just the innovation that's happening, but also the reliability and repeatability of the systems. And again, the system integration. So
A couple things on this. It's a great system. One, Aaron, I appreciate you demonstrating it for us. There's oftentimes in the middle of the night, I get a ping on my phone and it's a text from Aaron saying, hey, I'm going to go fly this or this is happening. Do you want to watch? And then he'll send me the live link so I can observe it from I'm in my living room. He's at his house flying and this drone is somewhere in the state. And one example, these systems that are totally off grid, we have one on the Mexican border looking at a project down there, the Otay Mesa project. And we did a little demonstration where one of his colleagues in Alaska was able to remote in, fly this drone on the Mexican border as we were able to sit there and watch a live feed from anywhere we want to be. So we're really trying to play with this, looking at the cases that it could be used, strategically try and deploy them in the appropriate places around the state, not just for digital construction management and inspection, but also, like you said, for emergency response and other things. So that was all we had. Anything else you want to mention on the drone or the dog, Aaron?
Nope, that was it. Anybody has any questions, feel free to look me up on LinkedIn or email me or anything like that. I'm happy to deep dive on anything you saw there.
Okay, well, I appreciate your presentation, Aaron, and I will pass it back to Tisha.
Such a great presentation. That's actually the second time I've got to see that, and it never gets old. So right now we're going to open it up to any questions. I haven't seen any. There was a comment saying, "Wow, we can switch between the IR camera and live stream." So that's cool. I did have one question come through, and what do you do if you get in a situation where it's I've fallen and I can't get up with the dog? Like, does it ever flip over, and how do you retrieve it if it does?
Yeah, sure. So that system actually is self-righting. So unless it gets itself into a very precarious situation, if it does happen to fall over, it's able to right itself right back up again. So if any of you seen America's Got Talent recently, Boston Dynamics actually has, I think they have 5 or 6 of effectively that same system, except with a robotic arm attachment, that they're dancing live on stage. You'll see them fall over, they get right back up again. The Boston Dynamics is really trying to kind of democratize the technology and remove some of the stigma of, ooh, that's weird. I don't know if I like robots in my living room kind of thing.
So what'd you name the dog?
So the first one we named Stompy. We've got a second one that we're in the process of deploying right now that is yet to be named.
Okay. Couple questions.
Maybe
in.
Tisha, that should be something for the next COC, as we have a naming competition.
Oh, I like it. I like it a lot. How much does the robot cost, and is it cost effective for reducing project expenses?
Yeah, I mean, the cost is really variable. A lot of it depends on the radios, attachments, etc. So the base unit itself is a little under $100,000. And then you can go up from there again. There's $1 million payloads that you could hypothetically put on the thing if that was so inclined. So it really just depends on configuration. Much like buying a vehicle, right? You buy the base vehicle and then you buy all the upgrades or things that you want to go on it. So very configurable. It can take a whole bunch of different types of payloads. Effectively, it's just an Ethernet bus. So anything that you can control via Ethernet, you can bolt to the thing and kind of operate with it.
Okay.
With that said, Aaron, you did a calculation, and I don't recall the number, but just on that one culvert, what was the magnitude of estimated cost savings since we didn't have to do the exploratory digging?
Yeah, with the reduction in the exploratory digging, the confirmation that we didn't need engineered shoring, and again the exact quantities and depths and staging that we were able to provide the contractor. Effectively, it went from what we used to or would have done with an emergency project to having design level quality information provided to the contractor via our connected data environment. So we had kind of a soft estimate of at least $100,000, and on the higher end, it could have been several hundred. Again, because it probably would have taken another 3, 4, 5 days by the time they did all the excavation work to ascertain the true extent of the damage, engineer the replacement versus, literally within 2 hours of collecting that data, we had a fairly sound engineering decision made and details to be able to share with our contractor on what the repairs needed to be, what equipment they needed to order to get on site, etc. So turned it basically from force account to almost like a design bid build project as far as efficiencies.
Okay. So one of the questions was whether you did a benefit cost analysis, but I think you've kind of already answered that. Is the drone photogrammetry and LiDAR survey grade data, can it be done based on the point cloud file developed from the drone imagery?
So loaded question, but yes, it can be survey grade if you're following the correct protocol. So that system is RTK PPK capable, meaning it is very capable of doing quote unquote survey grade data. I want to use that term very lightly because survey grade is a loaded thing. It involves a lot of processes. It involves having our partners from our division of land, for us at least, involves having our partners from the Office of Land Surveys involved in the entire process. They're helping us with project control, ground control points, etc. But yeah, at the end of the day, you can get sub 10th of a foot horizontal and vertical out of systems like this.
Okay. Do you know how many states are currently using this technology for construction inspections?
Which one in particular? Are we talking robotic dogs or the dock-based drones?
Well, I'm not 100% sure because it's a comment that came on, but maybe both. So I know.
Yeah, I mean, I can answer a little bit of that. I believe Texas DOT has several robotic dog systems. Alaska DOT is using them for wildlife mitigation up in the Fairbanks Airport right now. We've got several of those systems. I believe there's at least three that I'm aware of, at least. As far as dock-based UAS systems, I believe it's now 3 or 4 states. There's probably some folks on the line from Skydio that probably have a much better answer on that, but I believe Ohio DOT has several deployed. I know we've got several units deployed. Alaska DOT has units deployed, and there's probably another dozen that are out there that are in the process of starting to deploy these systems at scale.
I think I'll just add, when you talk digital construction inspection in general, and this was more of a general question, I think any state that's looking at BIM and models is starting to use more rovers for grade verification. So it is pretty widespread. But at the same time, we're all learning how to use it in new ways. I think there's another question that you're going to come to about, can you do the terrestrial scan with the dog above ground? Absolutely. Where I first saw the dog employed was in vertical construction, and they programmed it to walk every room every day to do the scan for the status of construction. And the neat thing about it is it's smart enough that if it's going in a stairway that it would normally go up is blocked, it knows and will find a different way around to be able to complete its routine. So you could do it in a vertical construction. We could do it horizontal. We're looking at it where if we don't want to send surveyors out or engineers out, say an active slide, I would much rather take the risk of losing a dog to put it out there to start seeing where those headscarps are and other things. If we couldn't do it with a drone. Now, if we could do it with a drone, that would be much more safer and efficient. But if there's heavy surface cover or vegetation reasons why we couldn't use a drone, or if even it's heavy fog out on the coast, we could use the dog in those instances as well.
Okay. So this is kind of a two-part question. I know in New Mexico, whenever I bring up something new, the contractors are all over it. They want to join in, they want to help, they want to do anything to get us more productive. But do you find that states are finding contractor pushback or pushing more for digital information? And if so, what kind of resistance did you experience in the initial phases of introducing these kinds of technology?
For us, we've been working closely with AGC, Yukon SCCA. My big focus is that we can't leave our small and mid-sized contractors behind. We have to make sure whatever we're employing, we give them the right tools and education. It's really about education. And, Sean, I'm sorry, we didn't come back to you about the labor compliance side of everything, but that's been a growth for us too, as well as we started using B2G now and bringing our contractors. There's a little bit of pushback there at the beginning, but that's part of that change management. And I don't know if you want to add anything to that, Sean.
Yeah, and it's a good question, because as the states gain confidence in a lot of these digital construction management tools, whether it be models, whether it be a software like Elations or drone usage, LiDAR, mobile LiDAR, things like that. We need to take into account the contracting community and how it affects them as well. We're working with our AGC to find, and we've got a small working group going that we just actually put together, that as we develop further into 3D modeling, we want to make sure that we're giving the contractors what they need and not what they don't need. And for us, as state agencies developing a 3D model, lots of times we're developing a 3D model that's covering many design elements that are important to us, or important to a permitting part or a right-of-way part, or, something that's really relevant to the DOT. But when it comes down to a contract and a contractor, is that information exactly relevant? So we're trying to minimize how much information gets basically culled out of a 3D model and give them a product that they can use, and then they can break it up as their subcontractors need information, or a fabricator needs information. And then the other part of this is too, we've kind of talked about this, and that was a big discussion with the domestic scan as well, is gaining that trust and that confidence in that data. When mobile LiDAR was coming out years ago, there was a lot of, well, how accurate really is it? Can we really trust what we're getting? And the same thing with a lot of our digital delivery tools is it going to integrate with our payroll system? Is it going to, as our inspectors, as they accept a product and it populates a payment system for us to pay the contractor, is it going to pay the 2 that we put in, or is it going to pay 20? We need to gain that trust and develop that trust through use. And I think we're all pulling in the same direction. I think our contractors are pulling in that direction as well, because they see efficiencies from their side as well, not just from a layout perspective. I think they're finding all kinds of different tools to use. Different software platforms are being developed for them as well. So yeah, I think I have not seen in Maine a lot of pushback. I think it's a lot of push forward. We need more. We need more data electronically and not so much on paper.
I'll just add to that, Tisha, that in California we did the same thing. We're looking at BIM. We've assigned a actual principal engineer at the department, a whole new position to implement our BIM program. And as we did that, knowing that we needed to bring the contractors along with us, he initiated a annual BIM summit. And in that summit are our contractors, the builders, our subcontractors. We have a lot of small businesses that are scared. They're scared about what this means because it's going to be a change. So we need to make sure their voice is there. But then we also have the software vendors that, okay, this is where we want to go. And if your software doesn't get there, they know now how to figure out to get there. And from that, we are learning that our software vendors are now collaborating with each other. It used to be fully competitive. Now it's like, oh, how can we support each other to get to where the department wants to go? So really having all those voices in a room once a year and allowing everybody to log and voice their concerns and hurdles, then we all can look at it collectively at how do we manage those changes, how do we resolve those or eliminate those barriers, and then move forward without hurting our competition, because we want all the contractors to be able to get there and not just the big few.
Yeah, and Ray, I want to add too, we're in the same spot as far as not leaving small and mid-sized contractors out of the loop. Maine is it's a big state geographically, but it's a small state from an industry perspective. And we do have a lot of family-run businesses here that, that will take a lot of our smaller and mid-sized contracts. And that's been a big concern of us in a 3D model, development is, how much do we invest in 3D modeling, what type of projects, because we don't want to rule out those smaller contractors from bidding our work that may be of a smaller nature. And really even the smaller contractors are jumping on board. Just recently, we actually had a box culvert replacement bid, and it was a $500,000 bid, and it was a small company, small family-run company that took the bid. And right after the award, we got an email and said, "Hey, can we get a model?" Because they had a consultant engineering firm relationship with them that took it and produced an electronic plan that they could use. So I think, I think industry is growing. I do think, the concern of leaving out small and medium-sized businesses is very real, because we do not want to exclude anybody with our advancements, but we do need to have that cooperation, and we need to hear from our industry partners on how we can make that best fit for everybody.
Okay. This is kind of a 3-part thing. They all tie in. So the first one is, that's a lot of data. Over the years of use, how do you anticipate your data storage needs changing? And then have you had any issues with sharing data between the agencies or among the stakeholders who need to use it? For example, is there any kind of advanced work that you need to do to ensure that your systems are compatible for handling the data? And then someone else just asked the question kind of along the same lines. Can you speak to the importance of developing model authoring tools by DOT to create the design model elements efficiently in a standardized state that can later be feed asset construction and asset management? That's a lot. I
No,
know.
I can start on that. Data is the elephant in the room. The data storage, figuring out how we're going to do that, where we're going to do it. We know we can't do it on premise, although we want some on premise backup. Looking at different cloud service providers. I think one of the most significant things is as we start using different softwares as a service to ensure that we own the data, regardless of if our contract expires or they go out of business, we have to have ownership of the data. Now, managing access to that data, we're still struggling just with that internal access and what data is important to create. At some point, we do need to look outside the firewall, read rights, data entry rights, what we are going to be requesting from our contractors, so we have that data management flow. But that last question, I think, is a really important question, because data is important, but BIM is not a design and construction thing. It really is. We're looking at it as a life cycle management, asset management thing. One of the taglines that our group is using is projects before potholes. So as we build, and this model, this digital twin is floating in the cloud there. And I like to use the example of a culvert. Every culvert inspection gets tagged. The quality of that contract gets tagged. So then we can start looking at the degradation of that culvert. And then we can start doing predictive planning instead of just saying, well, it should be there for 50 years. If we start seeing some decline, we could do some predictive planning and then really manage that asset and replace that asset before there's a failure. And that can go with any of our electrical assets, any of our roadway assets. When we do a road condition survey, we could start looking at that, how it goes. So BIM really ultimately is that asset management tool. Construction is a huge part of it, and those digital as-built is a huge part of it. And I assume a lot of the states are in the same position we are. We really have no idea what's underground. Our own utilities, other utilities. So we're trying to get that as one of our first steps, is to create that digital model of everything underground. Now, back to the original question, that's a lot of data, and managing it. Our IT is struggling with that. Our whole data governance group is struggling with that, to figure out where it's going to live, how it's going to be maintained, and who's going to have that access. Sean?
Yeah, I'd agree 100%. And I also think too, things we've talked about here in Maine is, on the asset management side, how do we streamline passing from construction and, accepted materials, accepted products into our maintenance folks, and not lose that data somewhere along the line. And also, one of the things that I keep talking about that I would love to see as part of, our digital as-built that goes to our maintenance folks is, I use the example of a traffic signal system. We've got a controller cabinet, we've got foundations, we've got, aluminum mast arms, we've got, red, yellow, green lights, LED lights. The way I look at True BIM is, once we've accepted something in construction electronically, we can transfer that to our maintenance folks. Maintenance should be able to click on that asset, whether it's the cabinet, whether it's the foundation, the mast arm, the actual signal heads, and find out when were they put in operation, what's the make, model, and serial number of those. Because if we start seeing a particular trend, much like your culvert example, if we start seeing a trend with a particular electrical component or a particular type of foundation, or a breakaway, if we have a breakaway on a foundation, if those assets are managed properly and we start seeing trends, then we can start reacting and saying, okay, we need to go find out where these things are and do a little bit more deep dive, and maybe we need to make plans on replacing them. or not use them again. You know, if the LED lenses burn out every, 17 and a half months, if that's managed through a true asset management model, we should be able to say, okay, maintenance has gone out there and replaced these LEDs 16 times, over the last 10 years, and maybe we shouldn't use them anymore. And so, I would really like to see that level of data going along with shop drawings, foundation design, where things really are, and including electrical connections, internet connections, things like that. Because again, things change in construction from plans. And if you hit a rock or unsuitable materials, or you have another utility that's in the way and you move your facility to get around it, that's also important as well. So, I agree 100%, Ray. I think, being able to track all that in a sensible manner and where to store it and how to store it is important.
So asset management would be fantastic use of this technology. Is there something that either of you would like to do in the short term with the technology that you have now? Do you have any near goals that you want to try out with these things?
Well, I think for us, personally, I think really sitting down with our designers, our maintenance folks, and our planning folks, and really coming up with the top list of what is our most important assets and start identifying them all the way through the process. So when we kick off a project at planning and we know that it's, an intersection project or a large culvert project that has, guardrail ends on it, if we know that there's a top list of assets, we can start right off the bat to say, okay, this is what we want. We want to make a design. We want to link that asset type to our design element, to our construction element. And as soon as it's paid for and the date it was activated, it can go to maintenance and really streamline that thing. But we can't do that with everything because we're at a different level of development. Everybody's following their own path, but I would really like to start with linking our asset, our very important assets to these things and then build upon that, and be able to be able to help that data transfer so we don't duplicate things. And what's important to us right now is our priority.
Okay. And Ray, I know that you've got the drones, you've got the dogs, you've got the cool tools, and I know that you showed us at our WashTow meeting that you were using the drones to hang lights out in the middle of the night in the boonies. Like, what else do you want to try with these toys that you have?
Oh, that's the vision that and the enabling others to act, let Aaron run with. Some of the things he's proposed to me or talked about is using some of these high definition cameras and LiDAR, vehicle mounted, where we could do ADA inspections, use AI to do ADA inspections on all of our curb ramps and sidewalks. So we could have a true inventory of where we're in compliance or out of compliance. Because right now, quite frankly, our state highway system is so large, we don't know. We don't know all those areas. So, that's one. And then really continuing to push towards getting the geospatial sandbox digital twin reality, because we're collecting all this data. We're collecting digital as-built. Aaron's doing a lot of these flights. There's no reason that cannot be permanently stored as part of our digital twin of the state highway system. But we need to resolve that issue really, in my mind, short term, because if not, the data being collected at someday will overwhelm us. And then it'll be back in the old days where we would send surveys out, they survey for a project, we build a project, and all that data gets thrown away. And 5 years later, they're out doing the same work again. That could be said the same for our geotechnical engineers. If we're doing log attest borings, in geotechnical terms, the earth doesn't change that quickly. So we need to store all that data and know what material we have so we can keep perfecting it year over year. But it's one of those things just getting started. And going back to your question, really thinking outside the box. How can you use the tools we got in new ways and innovative ways to solve problems that we have?
Right. We've got some comments I'm going to go over. So MassDOT is currently developing an SUE program. So we'll let them do all the hard work and we can just, talk to them when they're done. The importance of the common data environment is becoming a central key in the data puzzle. And do your respective DOTs have job classifications to manage the data and govern it?
Well, yes and no for us. We have an office that is really our data governance lead. And we have some data governance experts, but they're doing everything that the department through our dashboard. They're basically they're the dashboard creators and the dashboard people that maintain all the data that we need to search on. So there are some, but dedicated to an effort like I mentioned about a common data environment going from planning to design to construction to maintenance and being able to manage that. No, we will head there as this develops because I think that's going to be a need to have one person to be able to interact with all of our internal departments and as well as our MPOs because lots of times we do capital improvements in the MPOs that have signals and other asset types that we wouldn't maintain because it's inside their limits, but we need to transfer that to them too, so they can maintain those facilities. So it's something that's in our, long-term range that we will have to have those type of experts, but we do have people working in that environment right now and trying to herd the cats, so to speak, to get us all pushing in the same direction.
So your management has been supportive of creating new positions to kind of cover this stuff, or is that kind of a more with less type of scenario?
Well, right now it's a little bit of both. They have been supportive because they see the need. However, much like every state agency, we are seeing retirements, we're seeing folks leave for different opportunities. It just seems that as soon as one person changes a position or leaves or retires, that hole needs to be filled. And lots of times it's nobody, or many times you just can't hire someone off the street to just set in there and do it because there's our practices, there's our way of doing business, and you've got to have that institutional knowledge. Supportive of getting new positions. It's just where those positions are coming from and what their turnaround time is going to be before they're really into a production mode, so to speak, where they're working independently and working towards the goals that we need in those respective positions.
And I'll add that we have leadership support. Our chief engineer, Donna Berry, has been really a key pusher on this. She did create that new position for the BIM program, putting a principal engineer in that. And we have a lot of very talented, smart engineers and a lot of talented IT staff. But what we don't have, because as a state agency, we're finding it hard to compete in this area, is data scientists. With what the data scientists coming out of school can make in the real world compared to as a state agency, we're having a hard time struggling with that, figuring out, okay, these are classifications that we do have in our pool bag, but attracting anybody to that. So we're trying to manage with smart engineers and smart IT folks. But I think in the future, we really have to start strategizing the data scientists, the specialists that are going to be able to do the work.
Which is part of that change management, right? Typically, we're hiring engineers, we're hiring surveyors, we're hiring geotechnical engineers, and now we're changing some of our needs. We're hiring different people. At Maine, I've led our summer internship program for several years, and for the last 2 years, I've actually hired some students from colleges that are in a computer science or computer programming background to help us clean up some of our data and some of our old databases. We've got a lot of old Access databases. Some of them still are used. Some of them are kind of just sitting there and we need to transfer them. And there's been a need to hire some of those folks that has a strong computer background that can get things done efficiently instead of someone that, is focused on a design component or a structural analysis or geotech soils profile and strength analysis. So I think it's part of that change management we talked about earlier is as this technology develops, you need to start looking at different disciplines to complement your staff.
And I see the comment from UDOT about Andy. Thank you for the director of data analytics and governance last year that was developed there. I will just add that our director just created a position for AI, a director of AI at the department, looking at how we are going to capitalize on that, because this is one of those things that's, I won't say over the horizon, it's here. So we need to know how to leverage it to improve our process and our systems.
Okay. Looking ahead and maybe a few last words. What has been your biggest lesson learned in your digital construction management journey thus far? And is there any knowledge you want to pass along to states so that they can avoid the challenges that you've had to overcome?
For me, I think the biggest lesson learned is you can't be afraid of failure. And, there is the paralysis through analysis and waiting for that 100% answer. And we implemented certain programs and I won't name the programs, but they were a necessary first step. The staff hates them. They're not really functional. I get it. And I talk to the staff all the time. Why did you make us use this? Because I had to get you to put down the pencils and get rid of documenting everything in PDFs. We have to switch to data. We have to change our paradigm from information gathering to data gathering. So I think the biggest lesson learned is don't be afraid of these incremental steps, because every step is going to be a learning process. It's good. There's going to be success in every step to some extent, and it'll lead you to that next thing. So, and the other thing is really capitalizing on our industry, letting them help us. We can't do anything without them. We don't build stuff. We need them. So let them help us build these specifications, policies, procedures together so we can continue to be an owner of choice and be more efficient as we start implementing things.
Yeah, and I'd add, I agree, Ray, 100% with all that. And I'd also add empowering our field staff to ask to try new things. If a contractor approaches them and says, hey, I've got this, new thing, let's try it out. That's where a lot of our smart work zone technologies have come from, with contractors saying, hey, this has worked in other states. Or the parent company has offices in Florida and I'm here in Maine and they're using it in Florida. Can we use it here in Maine? I think as agencies and as supervisors, managers, we need to empower our people to ask, can I use this? Because this seems like this fits the application. The other thing that I try to instill in our staff is anything new, and I don't physically mean going up and break it, but let's try to break it to figure out how we can make it better. Don't take the rover and throw it on the ground and break it and say, oh, it doesn't work. But let's go out and really use it, and let's find out what we need to change to make it better for us. Don't be afraid to ask questions. Don't be afraid to talk to our survey units that may already be using a similar thing and have them come out and maybe explain a little bit more, or talk to the contractor and say, how are you using it? And maybe spend some time and open up that dialogue, because lots of times we give them new tools and you have 50% it being used, or 50% it's going to go in the closet. And then you show up a couple months later for a progress meeting and, hey, how's that new rover doing? I haven't taken it out of the box. I don't have time. So I think we need to empower our folks from a couple different angles. Let's embrace that change, give them the tools to use and try, and then have that dialogue afterwards to make sure that we're making those adjustments to make things better for not only us, but for everybody, contracting, community, and everyone.
That's great. I mean, you guys have so much more knowledge. Thank you so much for sharing it with us. Thank you for all the participants for joining us. Big thanks to you, Ray, Sean, Aaron. Fantastic presentation and great dialogue afterwards. The recording of this session will be posted on the JTCEES site that Tricia will distribute after the meeting, and you will be sent a PDH certificate after the session. Please make sure to check your junk mail. I hope everyone can take home at least one thing that they learned here today to apply to your department, take up through your leadership, start rattling some chains and let's get some stuff moving. We are planning on continuing these webinars again after our annual conference in September. If you have any suggestions, please reach out to someone on the steering committee or work through the technical subcommittees in which you're involved. That's a great segue. So Committee on Construction is meeting in Palm Beach, Florida in September. Registration is now open and we're looking forward to getting together for another great year. We always learn so much, and I've heard we may see alligators. I'm not sure. Just to end up, we have a little joke for you. Why do golfers always carry extra pants? In case they get a hole in one. So thank you, Casey, for that. Thanks again. If you have any feedback on how we can improve these events, please reach out to Casey or myself. Have a great and safe weekend. Thank you all.